Right. Friends, today the session is going to be pretty interesting, and there are a set of questions that I'm going to discuss, which are very basic for operating system concepts. Particularly, we are actually lying in a period where we learn only theory. So I'm going to change that pattern where we are going to learn a lot of practical stuff, and I have put the questions here for your display. There are about 10 questions, and in addition to it, there are two questions which we may see or we may not see, and that's up to you to scroll through it fast at the end of the session. But these 10 are pretty much mandatory for me to go through it. So, first, what is a mount point and where can we see it? So, first, this is the terminal that we normally use for all the purposes like giving the command, running the code, etc. etc. All these are done through the terminal, and this is the place where we are going to live our next 15-20 minutes through. Now, what is the mount point? CD space slash. When I give, you can see that there is a change here, and this slash is referred to be as mount point. So how do we understand it? When I put a pwd, print working directory or present working directory, I'll get it as slash, and that's where all the file systems are mounted. What do you mean by that? The file systems are all connected under this mount point. You can see that there are so many file systems available here, and all these are mounted under this mount point. That is to be understood. That's why we call it mount point. And we have so many file systems here. Bin is called as binary file system, dev file system, mount file system. We'll have something called as proc file system. All these are the file systems that together build Linux. So what do we have in the bin? Bin will have all the commands, binary of all the commands. You tell me a command, that command will be available here as a binary. So someone would have written code for that, and that has been converted to a binary, executable file, and then that link has been given here. That's it. Any command you have, all those commands will be available here. Prwd, just now we used, that's available here. Rm remove, rmdir, all these are the commands that we generally use, and all those are available here as an executable file. Likewise, there are multiple other file systems. Each of them have its own purpose. So please understand, mount point is the place where we have all the file systems mounted. And where do the file systems reside? The question is already answered in the question 1. Now, identify the file systems that occupy no memory space, and we need to find out the reason for the same. Now see this is a beautiful question. When you see this carefully, you've got many file systems listed here, and right from mount, if you see, it has been presented with the size of the particular file system. Each of these file systems have got 4096, something like that. You go through it carefully, you will have something called as PROC file system. This PROC file system has got only 0 bytes of memory occupied. 0 bytes of memory. What do you mean by that? PROC file system has got only 0 bytes of memory. What is the content of PROC? PROC is the file system that tracks contents or tracks all the processes. You see that there are so many processes running in the machine, and all those are given a number right from 1 till the last process which is being run in the machine right now is all given a number here, and all of them are tracked. So it is the hub where all the processes are tracked, but it occupies only 0 bytes of memory. Why is it so? Simple. PROC is the file system that gets itself updated on the fly. What do you mean that? I update myself on the go. Now I am 1 KB, next minute I may be 2 KB. So I will keep myself updated about the size that I need to be held. So I need to find out how much space do we need to have really to accommodate each and every process, and gets updated quite frequently, and that's the reason while it is getting updated on the fly, we get nothing inside as the total space shown. But really to understand, proc holds all the files, all the process together united. So this is one of the most important questions from the interview perspective. They will ask why proc does not occupy any space. You need to tell that it updates itself on the fly. Hence it appears like it does not occupy any space. Now, create a process for creating two text files, txt1.txt and txt2.txt. Well, this is a good question. You need to see this way. I have the files readily available with me, and I can show you the files that's available in my desktop. So we'll see the files right now. It's a pretty simple file. I have got a file by name open.c. I have already typed it. For the want of time, I am not typing it again. So you see the file here. What do? I have one header file by name stdio.h. We know we will have to marry that and live with that forever. And we have couple of file descriptors fd1 and fd2. I'll tell you what is it little later because there are questions regarding it. Forget it. We are collecting the return value of the function or of the system call, to be very precise, called create, creat, creat and not create. Now I am creating a file by name txt1.txt. The permissions are read, write, execute for owner, group and others. Same is the case with other thing. So now I created this. One major thing that you guys need to understand is I've got a while of 1 here. Why do we have it while of 1 here? If I remove it, the code will be executed immediately and the process all dead. That's all, it's finished. The file should have been created and I will not be able to analyze anything. That's the reason I'm keeping while of 1 here, for it to run continuously until such time I say that goodbye, go ahead and do your work. Now I'm going to run this to show you if really the code that whatever we have typed is working fine. Now see that. Now how do we run it? gcc -o tell me a file name. I love Sachin, so Sachin open.c. So now what is happening here? GCC is nothing but GCC is GNU C compiler. -o says that the input is an object file and Sachin is the name of the executable file that I want, and the file that I am giving as a raw file is nothing but the .c file which has got the code. Now I am compiling it. I hope there will not be any mistakes. Now /Sachin. So I have run it now. You see that it's hanging on the screen and I am not able to use the screen anymore. And this is a wrong way of doing it because I need something to be done here. But let's see the question one time to get a momentum going proper. Now track the processes created real time. Tag the process created real time. Now what do you want to do? We wanted to create couple of files txt1.txt and txt2.txt. Let's check if it has been created because we have already run it. You can see that here I have got txt1.txt and txt2.txt created very nicely, I believe. Or we need to see what did I do in the code. Let's check the code again once again. What does the code do? The code creates txt1.txt, txt2.txt it creates. So we need to check if these two are created. txt1.txt is here. I need to get into a folder called C Ubuntu. Let's do a check. You can see that here. txt1.txt is created, txt2.txt is created properly. So my question is answered. Now the next question is what is most important. To create a process, to create couple of files using one C file, we have to use the system call called create, and that system call will enable us to create a file with whatever name we want, with whatever permissions we feed that as input, and the return value is collected in something called as fd1 and fd2. Let's wait for this. We'll have to answer this question a little later and put it on hold right now. And why did this while of 1 come here? I need to tell you this, and the answer is connected to the next question. Track the process created real time. Oh, how do we do it? This is a good question. Now see that here the screen is really hanged. I do not have any control to the screen. I can't give any input now. The screen is null and void. So I do a control C, which is nothing but killing it. I'm killing it right now. Now I run the same executable file but with an ampersand. So that will give me something called as 2756. It might be different for you with a different number. So don't worry about it. So now 2756 is the number called as process ID. Okay, that's first question. We are tracking the process with the process ID, and how do we get it? We get it with an ampersand in place after the name of the executable file being given with /. So after the command for running it, we need to give an ampersand, and that's it. It will get you a number, and you can see a 1 here that shows that this is run for the first time. If I do it for the second time, I'll get it as 2. So please remember, all these are very simple questions, but you need to really track all these till the micro level. This information is very much needed. Now, what do we do? Is this process over? No, this process is not yet over. It is not yet complete. Sir, how do we know it, sir? Simple. Jobs. If I put, I have 1 running, 2 running. Both are Sachin. I have not yet killed it. Or to make it easier, I can find out using ps-al. Now see that I have 2 processes running. Both are Sachin. I didn't kill them. The process still running. The PID is 2756. and 2757. Both the processes are running. Coming to the point, sir, why did you use this way? This is for getting, I mean this ampersand is for getting the details of the process ID, while I gave a while of 1 here for making it run in the background until such time I say that it's all over, go sleep well. That's it. That's the reason I left it. Otherwise the process would have been over by now and I may not be able to analyze the process, which is your next question. So please wait until such time we get into the next question. Now what we do, we just wrote a code to create a couple of text files. I gave permissions, the files are created, I am running it, I am executing it. While executing it, I need to give an ampersand. If not, what will happen? The screen will be locked until such time you kill it. So I gave an ampersand to get the process ID. The process ID is the one that is used to track the process. Sir, where can I track it, sir? I already told you some time back. Let's just go to the same place again, cd/proc. So what is the process ID we had? 2757, 2756. Let us see if it is really available here. 2756, pray the God. 2756, 2757. These two processes are now available and they are listed in the total number of processes which are running in the machine. So this shows that we can track a process easily through this method. Now, can you open a process while it is running? Record the method you follow to accomplish it. Right, sir. This is a very, very good question. We have already got a process ID by name 2756. I hope you guys remember that 2756 is the number that we tracked some time back. Now, what do I do? Is this 2756 available here? We need to recheck it once. We'll check it first. 2756. It's available here. Yes, sir. So now what do we do? Can we go into the process? That's the question. Read it once again. Can you open the process? Yes, I'm going to open it. 2756. Now I got into the process, which means I open the process. That's it. So you can go into the process and this is the content of the process. We don't worry about what is this right now. I'll tell you this little later. But only thing is, while the process is running, you can open it. While the process is currently running, that's the reason I gave a while of one there. That will keep the process running and we can open the process with the process ID. The process ID is nothing but the ID that we get while we run the command with an ampersand. I hope it is clear. Now, identify and open the PCB in real time. Is this possible? Yes, it is possible. The one that I have shown you in front of you is called PCB, which is nothing but the process control block. What do you mean by the process control block? It's as simple as that. It's the diagnostic report about each and every process. So all the process will have a complete medical report about itself while it is running, and anybody can go and find out what is happening in the particular process using this. For example, it starts right from CPU set. You can see the CPU set here. Amount of CPU it is being used. Amount of stack space we are using. Complete statistics. Session ID, everything will be available here, and all these are nothing but the diagnostic report or the complete prognostic report about the process which is currently being run. Only thing is, you cannot open a process which is not running currently. You cannot do postmortem, you can do a live operation. The live operation is done on a process number 2756 here, which cannot be done if the process had been killed already. So guys, please understand, you can't operate a dead body. You need to operate a body which is having which is a live body, which is an operation has to be done only on the person who is alive, not on a dead body. Right. Identify the files connected to the particular process through a file descriptor concept. Well, this is a good question. We have already crossed 50% of this question through this explanation that I have given some time back to you. Now, the last question, I told you that we have created two files. One is txt1.txt. Another one is txt2.txt. So these are the two files that are connected to this particular process. Okay. So how do we track it? Before I go into it, in any operating system, particularly in Linux operating system, everything is a file. You are a file, I am a file, file is a file, input is a file, output is a file, error is a file, everything is a file, and that's why we call it file system. All the files are tracked properly with file system and everything is file here. Without file, nothing will happen and you will fail without a file. Right. Now, Sir, how is a file tracked in a particular process? The question, we have to read that question once more. Identify the files connected to the process through the file descriptor concept. Now, simple. I have two files for this process. Now, the file that has created the two files is one file that has become a process, which means the code that I had open.c has become 2756, and this 2756 has enabled me to create text1.txt and text2.txt, and these two files are to be tracked by the kernel properly. And how do we track it is the question. Okay, everything is a file here, and each of the files are numbered properly, and that number is called file descriptor. Simple. Sir, how do I get the number, sir? You can now go to the same code, fd1 equal to fd2 equal to something like that I have given here, right? This integer fd1, this is called file descriptor. This is called file descriptor. Simple. This integer is nothing but the return value that I get as an effect of creating this file. If it is successful, I'll get an integer number here. I'll tell you what that number would be. Similarly, I'll get a number here, and that's what is called file descriptor, and that will be available here in this folder fd cd fd. Now you can see that I've got 0, 1, 2, 3, 4 available here in front of you. Now the point is, sir, why 0, 1, 2, 3, 4? I have only two files available. Well, I appreciate your question. Simple. We have three things which are already available with us in a standard manner. One is standard input, that is my keyboard. Another one is standard output, that is my monitor. Another one is standard error, that's also my monitor in most of the cases. So these three are already available, and they are also files for me. So 0 is the number that I will allocate for standard input, which is nothing but my device. Standard input. 1 is the number that will allocate for standard device again, that is output. 2 is the number that I have allocated for standard device again. So these three are already available, and they are also treated as files, and hence we call it standard file descriptor numbers 0, 1 and 2. Now any file which is getting created after which will get the number 3, 4, 5, 6, and it can grow like that. The first available free number after 2 is 3, and it will be allocated for the first created file. And this 3 is nothing but the return value that I have got there to analyze. 4 is nothing but the return value that I have got there on successful creation, and this is what is called the file descriptor. And this is what is on the whole, this 0, 1, 2, 3, 4 is called as the file descriptor table. This file descriptor table is nothing but a part of the process control block which is available for each and every process. So each and every process will have the details about all the files that are being tracked, all the files that are being created in fact by itself in the run. So please understand, it is a process which creates couple of files for itself, and it manages it through the process control block through somebody called file descriptor. And the file descriptors are all arranged properly, and it is through the file descriptor table we are trying to understand it. This 0, 1, 2, 3, 4 can go up to something like 5, 6, 7, 8, 9, 10, like that. It can go as and when the files are created. For example, if a file is deleted in between, the 3 is available free, and if a new file is created, the new file whichever is created will get the number 3 and not 5. Once the free space in the beginning is filled, 0, 1, 2, forget it, we will not touch it. 3 and 4, we may delete it in the future. So if we delete 3 while 4 is remaining, the new file which is created will get number 3 and not number 5. This is an important question. Please remember, folks. Now, mention the way file descriptors are assigned to a process. I have already told you this. This 0 is for standard input, 1 is for standard output, 2 is for standard error, and 3, 4, 5, 6, 7, 8, likewise whatever file you are creating will get the number. How soft links and hard links are connected to the question number 9? Simple, I mean in the previous question. You can see this, right? 3 and 4, they are green in color. I have highlighted it right now. They are green in color. Why is it green in color? Because these files are not available here, and they are available in my desktop. But how do I refer it here? I refer it here through the address, I mean through the link, that is called soft link. If I have the complete file itself here and I am referring it to it, I call it hard link. To make it very simple, hard link is like copy paste, while soft link is like keeping the shortcut in the desktop. There is a command in Linux to understand that, which is called ln. ln is nothing but link. ln-s will help you creating the soft link, while ln source file, destination file will create the copy of the file, and if it is already available, it will overwrite it. So if you want to know more about this, you can use man ln. Man is nothing but the online man page, I mean the manual page. All these details are available here, and if you do not know how to use man page, you need not panic. Go for man. That man will help you in understanding how exactly you need to use man page. I learned everything only from man page, so everybody can learn. It's quite easy. Now I have optional questions that are given in the assignment. First one, how do you identify the process which consume more resource? Simple, but don't try this quite often because this command itself is heavy. This itself will consume a lot of energy. Top, TOP. When I do it, this command will get you the details of how much percentage of CPU is being utilized or how much memory is being utilized. Everything will be given up to date in real time. So this gets updated on the go, but don't use this unless and otherwise it is very much required. Top is the command. Can one be assigned as a process ID? If yes, how? Okay, well, we need to go back to the same proc directory. See this. What is the first number? 1. 1 you cannot assign. It is already assigned to the process called as init we call, and you cannot assign it. It's for the boot up process. So it's already assigned by the creators of the system. You cannot do anything about it, and it's the parent process of all the other processes which are here. It's like my great grandfather. It is there, and all these are the children of this particular father, right? I hope you enjoyed the learning. Thank you very much.